All right, I'm here in a classroom today because I wanted to talk a little bit about what this next chapter is going to be about, what you're going to be working on for this week 5, and wanted to have a little less distracting of a background. So this week, this chapter is one of my favorites. I think there are some really interesting topics that we can address with this chapter. So what we're going to be looking at is bivariate data, where instead of a single measure for an individual, there are two. The beginning of it, we're going to look at two quantitative measures and their relationship. Like think of points x, y. There's an x and a y measure of that point. So I wanted to introduce this by way of an example from this education data again, a really interesting one. So if you look at school data, a lot of people want to measure schools by test scores. So for elementary, middle school kids, that would be the percent of students that are meeting the standards. And for high school kids, it might be their ACT scores or the percent of students who are college ready in that. And then people will compare schools and say, well, look, this school is much better. So like for example, New Trier High School, which I think is on the north side, is 91.5% of their students that graduate are college ready. Whereas there's a Chicago school, North Grand High School, they're about 10.3% of college ready there. And so looking on the surface, we might say, well, look at how much better the New Trier High School is than this North Grand High School. But what we're able to do now in this chapter that we can look at two measures of an individual is we can maybe try to explain a little bit of that difference in the percent that are college ready by another variable. And this is one that we've looked at already. So what I have here, let's think about the relationship between the percent of students that graduate high school that are college ready and the percent of students that are low income in that school. And so we can have a vertical axis that is the percent that are college ready and a horizontal axis that is the percent that are low income. And so if you look in the state of Illinois, these are the points that you get. Every point here represents a school in Illinois, a high school in Illinois. And so New Trier, that seems to be doing very well, is actually just right over here with that really high percent college ready, but only 3.4% of their students are low income. So it's a relatively low poverty area. Higher incomes in that particular area. Whereas North Grand High School in Chicago, down over here in the corner, is 95.7% of their students are low income. So when we take this second variable into consideration, both schools are kind of fitting this general trend, and maybe there are other variables explaining the difference, that it isn't just that, oh, these students, they just don't study hard, and they're not working very hard. These students, these are the hardworking students. These students study hard, and the teachers are better, and so therefore the scores are better. So I don't know how to say this, but those kind of interpretations, they're crap. They're not true. There's a lot of other things that go into this, and as we can see here in this particular diagram, clearly, poverty has an effect on the students' ability to learn, their ability to focus at home, all kinds of other factors wrapped up in there. And so this is what looking at bivariate data does for us. There's a couple of key things we're going to look at. One is a way to numerically measure the linearity of this relationship. So we know there's this linear trend. How linear is it? And that's called the linear correlation coefficient. Then we'll also have a way to find an equation for the line that best fits these data. That's called the least squares regression line. And then there's some other things we'll do as well to say, okay, so I have this school, New Trier, and I have this least squares regression line. Did it fit the line what I expected? Did it outperform what I expected, underperform what we might expect? And same thing for North Grand. Does it fit this line what we would expect? Given its percent of students that are low income, did it underperform, overperform? And that's called a residual. Residual is the difference between what we observed and what our least squares regression line would expect. So a really interesting topic, lots of cool questions that can be answered and investigated with this particular chapter.